Can you see my screen now? All right, sorry about that. I hope it is visible now. Okay, all right, cool. Yeah, right. So you did not need much. We just covered what is Docker and what is Kubernetes. We haven't covered the Spring Boot part, so you haven't missed much. Just follow through the slides, few more slides, and then we'll jump into the Spring Boot part. So if you look at, we are the Kubernetes part, where Kubernetes is basically an orchestration tool for these containers. So when you want to run these Docker containers at large scale, you use Kubernetes. Then you can think of Kubernetes as an abstraction for your application. So just like this. So Kubernetes abstracts your applications from the underlying infrastructures. So you can compare with the pets versus cattle analogy, where you can treat your machines as cattle instead of pets. So if something goes wrong with your machine, you don't need to worry about fixing that machine. Instead, you can put a new one and then get rid of the problem-causing machine, right? So that's what that is what I meant by Kubernetes abstracts your application from the underlying infrastructure. It also means running your applications in a cloud-native fashion, like you can run on-prem or in cloud, like Azure or maybe Google or AWS. So once you develop applications in a Kubernetes fashion method, you can pretty much run these applications across any cloud environment with some effort, of course. But let's see what that effort is. But you basically run your applications in a cloud native fashion. That's what I meant by abstraction of applications from the underlying infrastructure. So, and then finally, what is OpenShift? We know we have Docker that is relevant for your applications. There is Kubernetes that is relevant for your deploying your applications. But why do we need another thing called OpenShift? OpenShift is basically this is what OpenShift in a one slide. You take Kubernetes. You have to put a lot of effort. I would say building tooling around Kubernetes, and then you put a lot of money, and then it becomes ready for using, right? So developers just cannot use Kubernetes out of the box. There is some effort that you need to put in to make it like production ready. So this is what OpenShift is all about. So OpenShift is Kubernetes, the like 100% Kubernetes, and then all the developer features that developers need to interact with Kubernetes and deploy applications, and then some other awesome features like networking, logging, security, and that are essential for any production applications. So you can think of OpenShift as a Kubernetes cluster, but with all the missing features that Kubernetes doesn't provide for developers. So when Kubernetes is mainly focused on operations, OpenShift is focused on operations and developers. Okay, so that's the reason we want to use OpenShift for this. So with that, that's all I have on the intros. Let's get into the demo part, the Spring Boot part. Oh yeah, here is another interesting analogy. I think of Kubernetes as a kernel for data center, whereas OpenShift is like an operating system for data center. The reason I say is with just kernel, you cannot do much, although it is a very powerful thing, but you cannot directly use kernel, right, to run your applications. You need some kind of proper operating system to run your applications. That's what OpenShift is all about. This is just my analogy. It doesn't mean the literal meaning, but that's how I understand OpenShift and then Kubernetes. Okay, so with that, let's go get started with the Spring Boot application development. I hope you can still see me. Let me see my screen share again. Okay, I think you can see my screen now. So what I'm going to do now is basically take a Spring Boot application right from the scratch and then deploy and then debug. That's the first step. So let's get started with that. So I'm going to go to start.spring.io. This is where you start Spring applications, right? So I'm going to say, I'm going to create an application which is a store orders API. So that API basically takes orders and then puts them in a MySQL database. So let's build that API. So I'm going to name this API as orders, and then I need web uh, actuator, and then let's say MySQL for my database, okay? And then generate my project. So this is going to generate my project, which is in downloads and then orders folder. So let me switch to that folder. I'm going to hide this. I'm going to switch to my download folder. Okay. I'm now inside that folder. So to make this application, this bare Spring Boot applications, to make it ready for OpenShift, all you need to do is include a Maven plugin. So that Maven plugin is called Fabricate. So the command for the including the Maven plugin is simple. So you can say Maven and then put the Fabricate Maven plugin latest version and then put a setup goal. That's it. Okay. And then when you do that, it is going to add the Fabricate Maven plugin into the pom.xml dependencies. I will show that in a second. Okay. Now, if I open this in a code editor, this can be IntelliJ. This can be, in my case, it is Visual Studio Code, but this can be IntelliJ as well. So if I go to my pom.xml file, you see that there is a dependency added automatically when I run that command, which is basically Maven Fabricate Maven plugin. This one, okay. So this is automatically added when you run that command. So now that my application has been ready, made ready for OpenShift, the way you deploy and then run the applications is pretty simple. Before you deploy this application, let's give a quick test to see if this is running properly. Maven clean package. So this should basically generate a jar file, and then that jar file you can run. So pretty much a standard Spring Boot workflow. Okay, so you can see it generated a jar file, and then you can run the jar file. But the goal is to deploy this application and then debug this application on OpenShift. So how do you do that? For that, I'm going to start an OpenShift cluster on my local machine. All I need to have is Docker for Windows, and then I'm going to start an OpenShift cluster like this. I just need to say OC cluster up. I don't need to put this version. I'm just putting it to show you that you can use in this way. But all you need to do is have a running Docker engine and then a OC binary. That's the OpenShift client binary. Okay. And once you have that, you just do OC cluster up. And that is going to start a OpenShift cluster as a container running on your Docker engine. You can also use something like Minishift that gives more flexibility on how you can run. But this is my favorite. I just use OC cluster up, and then almost in a few minutes, in a less than minute, I get my OpenShift cluster. So you can see a OpenShift cluster has been spun up, and then in order to log in as cluster administrator, I can use this command. Or if I want to log in as a developer, as a normal user, I can use this command. Okay, I'm going to use login as cluster administrator. I've just logged in, right? And then let's go to the UI. Here I can just say developer and then use any password. That is totally fine. So you can see my application, my OpenShift cluster is up and running pretty quickly, right? And then let's get started with the Spring Boot deployment, right? So what I'm going to do is create a I've already downloaded the Spring Boot and configured the Fabricate plugin. What I need to do is to deploy OpenShift, this application into the OpenShift cluster. I just need to run this command. That is fabricate maven fabricate deploy. That's it. Okay. OpenShift will understand that this is a Spring Boot application, and then I'm going to use a corresponding Java-based Docker image, and then deploy this application on top of it, and then convert everything into one single Docker image, which is my application image. Okay, so everything will be done automatically just in one step. That is your Maven Fabricate deploy, right? So when I logged in, I'm currently in the my project folder. To verify which project I'm in, I just need to say OC project, and then I'm inside my project and area, right? So I'm going to use this command, or the fabricate deploy command, to deploy this Spring Boot application into the OpenShift cluster, right? So I'm going to say deploy. That's it. So Maven fabricate deploy. So now, in the first run, there will be a lot of things happening because it needs to download the base Docker image, which has Java on it. But the subsequent runs will be faster. Okay. So you can see this is also pretty fast. It almost built and then created the Docker image and then pushed it. It's pretty much ready for deploying as a run application. So you can see a build has happened. You can look at the log from here, or you can see here as well. Both are same. So you can see application is built and then it is going to be deployed in a couple of seconds. Okay. Give it a few more seconds and it should be able to deploy application. All right. I hope you can still see me. So the application image is ready. You can see it is completed, and then the image is here. So I can go click on this and then see the metadata. It is using the fabricate base image, which has already, like this image, which already has Java in it. So it is going to use that as a base image and create an application image out of it. Sometimes this may be a network thing. I'm just going to restart the deploy. It doesn't hurt. It is going to deploy it again. I'm just retrying the same thing. If I go back and then look at the builds here, you can see a build is running, right? So the build process is basically there's a Java jar got generated for this application, and then it uses something called as binary deployment. So it generates a jar file and then deploys, uses the fabricate Java base image and then puts this jar inside that Docker image and then creates an application image out of it. Okay, pretty simple process. Now you can see the application got deployed. The build is success and then application got deployed, right? By default, in OpenShift, you'll also get a route for this application. So you can see my application has a route. This is the Spring Boot white label error. That means it is up and running. I can also do health check. So I can see it is up and running. Status is up, right? So within two commands, like one setup command, which is a one-time command, and then a deploy command, you're able to deploy a Spring Boot application onto OpenShift, right? Using the Fabricate Maven plugin. So now that the application is deployed, let's go and extend this application a bit and then see how debugging works. So I'm going to open this application. This is my application. I hope. Let me see. I want to double check. So this is my application. I'm going to create a REST endpoint, a pretty small REST endpoint. I'm going to say public string, say hello, okay? So just a hello world. I'm going to say request mapping, and then maybe hello, right? So when I hit the hello endpoint, it should say return maybe namaste, right? That's it. So the application is ready. What I want to do is deploy this application and then also maybe debug this application. So to deploy again, the same command, you just need to say fabricate deploy. And this is going to deploy the newer version of the application. And then I'm going to show how you can debug this application in a second. I'm going to check the chat and then answer the questions if you have any at the end of the session, so don't worry. So it has built and the push is successful, and now it's, if you look at the deployment, there's a newer version that is getting deployed. You can see OpenShift deploys in a A/B fashion by default, so it brings up the new one, takes out the old one. Pretty easy, right? That's it. So now if I hit hello endpoint, it should say namaste, right? So that's what our output is. Now I want to debug this application. Maybe I want to put a breakpoint here, right? And then I want to debug these applications. How do I debug? Go click on debug and then start debug. Based on your IDE, if it is IntelliJ, then there is some way to set up. If it is Visual Studio Code, there is a specific way of setting up the debugging part. But it is a very generic way. All I'm doing is setting up a remote debugging on the same machine, but on a different port. Okay. So I don't need any of the other fancy stuff. I just need a simple configuration like this, which says my application is going to listen on the debug port 5005 like this. Okay, so very simple configuration I've made. There is a similar setup that you need to do on IntelliJ that is only one time. It's not always, but the setup is a very generic setup. You just need to listen on 5005 port. Okay. Now, if I want to debug this application, all I need to do is just say fabricate debug. That's it. So what this is going to make is run the application in a debug mode and then forward the container 5005 port to my local 5005 port automatically. Okay. You don't need to do things like kubectl forward port, like all those, right? And then just use this Maven Fabricate plugin magic to do all this stuff for you, right? So if I go back, my application is running. I just need to say Maven Fabricate debug. So this is going to run my application now in a debug mode. So it is basically doing Java enable debug equal to true. So my application will now go inside a debug mode, so that I can go start develop applications in a debug mode rather than like a normal deployment, right? So give it a couple of seconds and then we should be able to ready to debug the application. Okay, so sorry about that. My application is ready. I go back and then say start debug. You can see my application has been attached to the running process that is running inside the container. So think of this debugging as kind of remote debugging, where although your OpenShift cluster is running inside your local machines, though, so that becomes like a local OpenShift development. This can be useful in cases where your application is running somewhere in the cloud, right? You can still debug those applications inside your IDE just by doing fabricate debug option. That's it. Okay. So now I'm going to set up this debug on my source code. So in the orders API, I have already set up at hello endpoint. So if I hit that hello endpoint, it should complain, right? Like not complain, but it should go to the debug mode. So I've hit that. You can see the debug went to this area, right? And then I can debug all my issues and then basically get rid of this debugging by clicking this button. Okay, that's it. So pretty simple to set up the whole thing. Although I've added a lot of explanation here and there, but to summarize, everything is done in just 3 steps. One is setup. So that is nothing but I'm going to cancel this and then show you this summary. So one thing is we have this Fabricate Maven plugin setup. That's the first step. And then we have done deploy. This is Maven Fabricate deploy. And then we have done something like debug. That's it, right? So within 3 steps, you are able to deploy your OpenShift application and deploy your Spring Boot application on OpenShift and also debug the application. Right. So this is for Maven related Spring Boot applications. There's a slightly different approach for the Gradle one, but if time permits, I'm going to discuss the Gradle part as well at the end of the presentation. Now my application is up and running, but my goal is to integrate this application with a MySQL database as well, right? It's not just deploying application in a standard mode, right? So let's go and deploy a MySQL database just inside the OpenShift itself, and then attach this orders API with that MySQL database. This database can be residing inside the OpenShift, or this can be an external database as well. So either ways it works. Okay, so let's go and deploy a MySQL instance. So this is how you deploy a MySQL instance for your OpenShift. It's pretty simple. You just say OC new app MySQL and then provide some environment variables like MySQL user, password, and then the default database. Okay, that's it. And then when you hit that, it is going to deploy a MySQL instance inside your OpenShift cluster. So you can see my MySQL is up and running in less than maybe 10 seconds, right? So this database is ready. My database is ready, but I want to set up some schema and then basically interact from my Spring Boot application. So the way I can set up schema is, again, you can interact with this MySQL container in various different ways. I'm going to discuss few ways. Let's say you want to SSH into that MySQL container. You can do OC/RSH and then provide that MySQL container name. And then now you are inside that MySQL container, right? So you can do pretty much any activity that you do, like logging into a MySQL container. So you can basically connect from local machine, let's say MySQL, and then password is put password as a password, and then DB as sample DB, right? And then MySQL, or sorry, password. You can see I've logged in inside that MySQL container, all right? So pretty simple. I have a script that I created beforehand. I'm going to use that. That is residing on somewhere here. So this schema, that is where my schema is. I'm going to curl that into my local instance and then load that schema into the database. Okay. So I've loaded that data. And now if I go and log in again and then show tables, you can see there is a customer data table. Of course, this can be an orders table, this can be a customer table, but in general, it can be like orders table, right? So my database is set up. The next part is integrate this API with that database, right? So Like I said, this database can be an outside database as well, maybe external database. In all practical scenarios, you will have database outside the container platforms. But maybe for development and then QA workloads, you can have these databases running inside the OpenShift cluster itself. All right, so the next step is to link this API with MySQL database. So the way you integrate this in a Spring-based applications is using the application property files, right? So you can say where your MySQL database is. So in MySQL database, um, in Spring Boot, one application can basically detect other application using something called a service name. So in this case, the service name is MySQL here, right? Um, and the service name for orders is like just orders. So this application can communicate with the other application just using this simple name called orders. So that's how the service discovery is made. So maybe if you're using Spring Boot, Spring framework, you might be using something like Ribbon or a lot of other application tools that you need to include inside your application to talk to each other. But in OpenShift and then Kubernetes, everything that is very generic, like the service discovery will go back into the layers that are below the application. So you don't need to put them inside the applications. They are already available for you. All right. So like I said, this orders API can talk to this MySQL container just using this MySQL name. So I'm going to put the details inside this application property files. I already have these details here. I'm going to cheat and then take those details. So Spring data source URL, I'm going to use the exact same details that I've already used for my MySQL instance. So the password is password, and then the host name of the MySQL instance is just MySQL. If you're using this as something like orders DB, then it should be orders DB, okay? But in my case, it is MySQL. And then I'm going to change my API to include MySQL related things. I'm going to just import these things and then add a method which says db test, which will go and connect to a table and then display some data. Okay, I'm just using the same table that I've already created, so don't worry if not matching the actual orders. But just to show you how you can stitch all these things together. Okay, so I have a method now called db test. So that is going to read the property file, right? And then basically make a connection to the Spring Boot or Spring Boot. So if you think some code is silly, just ignore that. I'm a Node.js developer. I'm just learning Spring Boot. Okay. All right. So I have this DB test endpoint that will basically what it does is it goes and talks to my SQL instance and then displays some data. Okay, that's it. So I'm going to test this. So I need to say again deploy, fabricate deploy, because I've made some changes. Let's go and deploy a newer instance, and then let's see if everything works. Okay, so I'll give it a couple of seconds. All right, so looks like the deployment is completed. Maybe we just need to verify if everything went smooth. So this light blue color means it is doing health check. By default, our API exposes health check here, right? So that health check is already used in this. So it is up and running now. So if I go to db test endpoint, okay, sorry, that's the wrong URL. So if I go to db test endpoint, you can see it went to my SQL container. It talked to the container and then shown some data, right? So it gave some data about the customer, which is what we configured here. So it showed customer ID, name, and then some age details. Okay, so that's what it shows. So pretty simple. You can see within less than maybe half an hour, we are able to deploy a Spring Boot application, configure a database. We are able to talk to the database, set everything we have set up for development and also for debugging, right? So this is all good. This is all happening inside your local machine. But sometimes what happens is maybe instead of providing these application property files as part of the fat jar, maybe you want to put that, you want to externalize that, right? So the way you externalize that, this property files is click on this orders deployment. I'm sorry. And then click on configuration and click on add config files, right? In OpenShift and then Kubernetes, there is something called as config maps. So config maps are basically like objects that you can store per environment. Maybe for dev, one config map, and then for QA, there is another config map. These config maps can be used as configuration, like application property files for the instances that are running in the corresponding environments. So what I'm going to do is, let's say my project that I have is a dev project. I'm going to create a property file. So the way I create is just click on this create config map and then put that configuration property files here. And then this name should be same as the application property files. Okay. All right, so create that. So I have a spelling mistake here. Application properties. This name should be same thing. There are some more use cases like to have more different names, but for now, to make it simple, I'm just going to use the same name. Okay, and then save. So I've created a configuration map file for my dev project. Okay, but in QA, it might be a different configuration map file. Okay, just keep that in mind. Although I've created a configuration or the property files, I've not used it yet. So to use it, select that file and then mount that file at a specific location. Let's say opt config, right? So I'm going to put this application property files inside opt config file and then add, right? That's it. So now my application gets redeployed. Still, we haven't configured Spring Boot to read that property file yet, but this is the first step. So we are going to supply a configuration map file or the property file externally, not from the fat jar, but from outside. Okay. So if I go inside my container now, this is how we can access it from the UI and then config. You can see my application property files is here. All right. So that's how you can configure a property file, but we haven't still said how to use this file from the Spring Boot application. Again, it is simple. All you need to do is supply a environment variable. You just click on environments under the deployments and then say spring config location. That's it. Okay. And there is another option called spring config name if you're using a different name for your property file. But if you use something like spring config location and then give the location like this, that is opt/config. I'm going to double check just to make sure I have it here. So you can see this is how you do it: spring config, opt spring config, and then I think this is location, not name. So let's give it a try. So I can just say spring opt config and then save. And this is going to redeploy again. And then use the newer config which I supplied or the external config which I supplied. Okay. So let it redeploy. Okay, that's it. So it is going to use the newer configuration which is applied. Now, if I click here again, reload, it is taking the newer configuration and then talking to the database. Okay, so this way you can externalize your configurations as well. You can also add storage. Let's say for your application you want to add storage, you can just click on configuration and then add storage, and then create storage and then provision storage from there. Okay, so that's another thing that you can do inside OpenShift pretty easily. Uh, so since my application is configured, what I want to do is set up a CI/CD pipeline to basically uh, do some activities like doing a unit testing or promoting that application to your QA environment so that QA can basically pull that and then deploy the application and test it, right? So that the basic CI/CD pipeline, let's take a look at that process now and see how simple it is to create that whole pipeline. So to create that pipeline, what I'm going to do is deploy a Jenkins instance. I'm going to use OpenShift Jenkins templates here and then create, right? So this is going to create a Jenkins instance, which is only for me, okay? No one is going to share this Jenkins instance. So have the complete flexibility of what all things I can do, what all automation I can do. It is all in my control, okay? Um, the way I think of using the CI/CD process in OpenShift is every team can have their own Jenkins instance. They don't need to share a single Jenkins instance, centralized Jenkins instance, and then wait on things. Um, Instead of that, they can have their own Jenkins instance and then set up all the CI/CD process. So in this process, I'm going to do things like do the build process again, and then do some unit testing maybe, and then also promote the application to a QA um, stage, right? So let's take a look. So Jenkins is a first-class citizen in OpenShift. Uh, it has tight integrations within OpenShift, so you can deploy and then authenticate based on your OpenShift credentials. I'm going to use a Blue Ocean newer UI. All right. So I can go and set up pipeline from here. So before I set up a pipeline, I need to make sure uh, I have pushed this code into a source control. So I'm going to say github.com Kubernetes Hyderabad, and then maybe create a new repo where I will put my source code, orders, all right, and then create. I'm going to push my source code here. So I'm going to take this and then push everything there, all right, as well. Okay. Now it is pushed, so I can see my code is here. So I'm going to set up a CI/CD process for this orders API that I've pushed here. Again, the setup process is pretty simple. Let me show you how good it is. So once you're in the Jenkins Blue Ocean screen, you can just click on New Pipeline and then select the GitHub part. If it is a generic Git, you can select this. It says it asks for a key. I'm going to generate its a temporary key for this demo. Kubernetes, just don't copy my key. I'm going to revoke it soon, but don't copy, okay? And then click on connect. So that will connect, and then you can see it showed all the repositories. I can go select my Kubernetes Hyderabad repository, and this repo doesn't have any Jenkins file in it. Okay, so that's why it is basically will create a new one. So I can just create a new pipeline, and then my orders API repository is here, and then click on create pipeline. Okay, so that is going to create a pipeline for me, in a UI that I can go and edit, or so if we already have a Jenkins file, then it will detect. Otherwise, it will ask for creating a new one. So I'm going to start fresh and then create a new one. So I'm going to start in this Jenkins Blue Ocean UI. The agent here is basically, I'm going to select something like Maven, which OpenShift already provides. So OpenShift will have something called as agents. Those agents are not running as of now, but those agents will be created whenever you ask OpenShift to create. All right. So we have by default Maven, Node.js, and a couple of other generic used applications. So as of now, I'm going to use Maven because this is a Maven-based build. So I'm going to say Maven and then add things like I want to do build first. All right. And the build will be a shell script which says Maven, and then Fabric 8 build, or I can just say Maven clean package. Both are same, right? I can say Maven clean package. Both are same. Now, once the build is complete, I'm going to say maybe do some unit testing. Okay, I don't have a very good unit test case ready now. I'm going to add some time later, but you can just say something like deploy and test, right? Deploy and test. And then add another shell where it says Maven fabricate deploy, and then maybe add additional steps for testing the application. And then I'm going to add a step which says if my application is good, and then I want to promote this to QA, I need to create a tag called maybe promote to QA, right? So I can do that. So I'm going to say promote to QA. So in that, I'm going to do steps like OC tag. My project name is called my project. You may be calling it different. And then this is orders API. So whatever the latest image that I've built, I want to promote it to maybe QA, right? So I'm going to say promote to QA. That's it. Okay, pretty simple. So this object, this Docker image that you actually tagged as promote to QA will be used by QA to test their own infrastructure, right? So you're basically saying this is ready for testing. Go and test it. Okay, so that's how you can visualize this. So I just said build, deploy, and test, and then promote to QA. I can also put a manual promotion process like only if I approve this, promote it. Otherwise, no. Right. So that is also pretty simple. I'm going to configure this. Click on save, and then configure this. I can see it's getting saved. So that Jenkins file will be saved to my Kubernetes here. So you can see my new file, Jenkins file is here. And then if I go back to my UI here, the OpenShift Blue Ocean, the Kubernetes Jenkins Blue Ocean UI, you can see that it executes all those stages that you have declared. Okay, so what are all those stages? The stages are 3 different stages. One is build, deploy, and test, and then promote to QA. So these all should be done in this pipeline. So it is now doing the first step, which is Maven clean package, and then it is going to deploy and test if we don't have any test, but if we have any test, then it will do that. You can also do parallel tasks. Maybe while you are building, you want to also, while you're testing, you also want to do like code quality analysis. You can add that as a parallel task, and then OpenShift will do that. That Jenkins OpenShift will do that for you, right? So I can see that it is doing a Maven clean package. And then the way these things are built here is pretty neat. So you can see a Maven pod has come up, which is doing all the hard work for you. Once the build is complete or the stages are complete, it is going to take out that container. So your Jenkins infrastructure is basically like a scalable on-demand infrastructure. So only when the build happens, these things will be alive. And then when the build is complete, these things will be taken out. Okay, so I can see it is completed. It is going on now. So if I go back here, you can see that all the stages are completed. So build, deploy, test, and then promote to QA. Everything is done. So if I go back to my images, so if I look at this orders image, I can see two of them now. So one is promote to QA, and then one is latest. So I can work on this. This will be dedicated to my QA folks so that they can go and test it. Okay. Like I said, you can put a manual process during this promotion thing, where only when you approve it goes to QA. Otherwise, it won't. So that is good for manual verification. So now that the developer part is complete, what I want to show you is how is QA going to use this application, or how is QA going to use this Docker image that you have tagged as promote to QA. Okay, so let's take a look. Before I do that, there are a few things I need to make sure from the permissions wise. So I'm going to create two new namespaces called QA and then maybe prod. Those are like next levels. As a cluster administrator, I can create those and then basically say that this guy or this girl has permission on dev, and then this person has permission on QA. So all those things can be done. Because OpenShift is a truly multi-tenant system, you can access control all these things for you. So what I'm going to use is create a folder called QA and then put all the pipeline in there, and then also do some other policies like setting up the permissions. So the way you set up permissions is we are going to create a namespace called QA, and then QA again will have their own Jenkins instance, and then they will have permission on your dev project, which is my project, to pull images from that project. Okay, so these two commands, what these two commands says is QA team has permission on the dev project, which is my project in this case, and prod has permission on QA because whenever QA approves a image, that will be promoted to prod. Okay, so these two permissions I need to set up. Before setting up, I need to create those two teams. I can just say create project and then QA, and then another project is called prod. Okay, right. So now that we have two things, I'm going to apply those permissions. Pins on dev, that is my project, and then prod on QA. So very simple. Now that I have that, to make sure I have a role called QA now. So I'm in a QA, I wore a QA hat now. All I can do is, if I want to deploy this application manually, I can just click on add to project, deploy image, and then go to my dev namespace, which is my project, and then select the application, which is orders, and then select the tag which dev said this is a tag you need to test. So promote to QA is the tag which I approved. You can go and test it. So I can just say this and then create, right? So once I do that, I'm going to have a instance which is specific to QA. So I can, this deployment is specific to QA, and then have my own URL and then everything specific to me, right? So as a QA testing person. Looks like I messed up some permissions, but it is as simple as that. Okay, I haven't given any permission. I only gave it to Jenkins, not to the original users. So I need to provide for user as well. So I provided only for Jenkins, you can see here. I'm going to say default minus n project. So that will give for the default service account as well. Service accounts, we can do it in a different meetup, but this is how OpenShift will protect different levels of security, right? I'm going to cancel this and then redeploy just to make it quicker. So you can see it is now getting deployed. So I can see now it is my QA link, right? So it's almost ready. Maybe it is doing like boot. Java applications take some time to get booted, right? So that's what is happening, maybe. All right, so the port is incorrect. I'm going to set this port correct. So this thing you don't need to do manually. I'm going to show the automated way. Since this is manual process, and I need to set up like the right port there. But otherwise, you don't need to set up any port. Okay. And the route, I need to go and update the route which I have updated in the service. Okay, I just need to select the one I configured. So if I do that now, you can see if I do hello, then it is saying namaste. So this is the orders queue API. So pretty easily, I can promote my application also. I can set up a CI/CD pipeline for my QA instance. So I can deploy a Jenkins instance specific to only QA, and then set up the whole process, automate the whole process of testing as well. So once I have the Jenkins instance here, I'm going to create a new pipeline on the same repo, just specific to QA, and then I can start from there, right? So that is also possible. So with that, I'm going to give a quick pause and then see if you have any questions. I'm looking at another window to see if we have any questions. Okay. Okay, I have some issue and I'm not able to see chats. But if you have any questions, just do one thing. Just tweet me here on this handle, twitter.com Debian Master. I'm there. I'm not able to see any chats from my mobile, but I do want to help you on the OpenShift part if you're stuck with any of the part that we discussed today. So we are about like 1 hour in the meetup. If you want to drop off now, you can drop off now, or if you have few more things to cover that I want to show, which are pretty interesting. But if you want to take a break now and then maybe follow up on the video, you can pretty much do that. I want to cover some of the Kubernetes parts as well. Let's say you're not doing it on OpenShift, you're doing it on Kubernetes. I would like to show how you can do that. So I'm going to get rid of my cluster, just say OC cluster down, and then it will take down everything. Okay, and then what I'm going to show you is how you can do the same thing. May not be all the features, but at least like deploying application and then debugging the application on Kubernetes. Okay, so the way you do it is on Kubernetes is just like OC cluster up. Kubernetes has something called as minikube. You can just say minikube start, and this will start a Kubernetes cluster on your machine. This Kubernetes cluster is using the virtualization that your host supports. Maybe your operating system, if it is Mac, then it may be using like the Mac virtualization system, or maybe a virtual box, or um, like if it is Linux, then maybe a Linux virtualization system. So all you need to do is download this binary called Minikube, and then maybe VirtualBox, and then you can get started from there. It takes a couple of seconds to start up. This is going to use about 2 gigabytes of memory by default. All right. So now my Minikube is up and running. I can just do things like kubectl get nodes. You can see my single node Minikube cluster is ready. Once my Minikube is ready, I can do similar commands like mabin and then fabricate debug. Is Minikube uses the Docker engine, which is running inside a virtual machine. So you need to talk to the Docker engine, which is running inside that virtual machine. The way you can do, you can talk to that Docker engine is pretty simple. You can just do Minikube Docker env. That gives you all the necessary commands to interact with the Minikube Docker engine. So you can just copy this command and then paste it. Now, instead of talking to your local Docker engine, it is going to talk to the Minikube Docker engine. The reason you need to do this is you can pretty much go away with this host Docker engine, but when you deploy applications, Minikube tries to deploy it from like a Docker image, which is not inside the virtual machine vision, so that there is some issue there. So you need to keep that in mind, and then basically use only the Minikube Docker engine. Okay, so now it is talking to my Minikube Docker engine. Once I have that, the steps are pretty much same, although you don't have that CI/CD pipeline, promoting applications, all the things are not there. But using Fabricate plugin, you can also deploy it to Minikube cluster. Okay, the way you can do it is, let's say, if I do kubectl get parts, it shows demo and then some other containers that are running. There is no orders API running. I want to deploy orders API. All you need to do is say maven fabricate deploy. Now, again, this fabricate plugin will convert all your source code into a Docker image and then deploy inside your Minikube. Okay, so give it a couple of seconds and it should be able to deploy your application. Okay. Now it's complete. You can see kubectl get parts. Your orders API is almost ready. It is getting deployed. It is ready now. Okay. Accessing this application running instance is a little tricky in Minikube. By default, there is no router inside Kubernetes, so everything is just inside that Kubernetes machine. It's not exposed outside. If you want to get it exposed outside, you need to do some manual tricks. So one of them is like exposing it over node port. You can just say, this is our API. I can just say some things like kubectl expose deployment configuration, that is this orders API, and then expose it on port 8080, which is the port on which this application is running, and then the type is a node port. Okay, so make sure you give this, only then it will expose it outside the cluster, and then maybe give it a name like orders node port. Right. So once you expose it, now it will be available outside. So you can just do kubectl get service. Now this is the port on which you can access the application. So to access the application, you need to find out the Minikube port, Minikube IP address, which is this one, and then 32680 port, right? So 32680. You can see the application is running inside Kubernetes, just Kubernetes, not OpenShift, but just Kubernetes. There is a slight difference, like you have seen. In Kubernetes, you have to do some little hacks to make it work, whereas in OpenShift, it is pretty much intuitive to develop and deploy applications. And then in Minikube, you need to configure Jenkins and all these processes like separately, whereas in OpenShift, everything comes out of the box. Okay, so that's the gist I want to give you, just to get a feel of how it looks like on OpenShift and then Kubernetes. If you have any questions, feel free to reach out on Twitter. I'm on this /Debian Master. With that, we are going to conclude this meetup, and then I look forward to meet you again pretty soon. Thank you very much. Thanks for joining.